Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson over area and circumference of circles. So first, let's talk about the different parts of a circle because these things you will find when we talk about the formulas to the area and circumference. So a radius is simply in a circle, it is from the center of the circle to the outside of the circle. So that is what we call the radius. So that is the distance from the center, and you can go any direction. It's to any outside point on that circle. So I could take that center and I could go this way, and that's the radius. We could go that way, that's the radius. So there's a whole bunch of radii, I guess, in this circle, and they all are the exact same measurement. So let's give it a random measurement. Let's say that that radius is 5 centimeters. Okay, now the diameter is the distance all the way across the circle, and it has to go through the center. So I'm going to change colors to show you then in the circle then. So notice it is going through the center, so there's one radius, and if we go the other direction as well, all the way across, then that is what we call the diameter. So the diameter is the distance across a circle, and it goes through the center of the circle. So there's a relationship between the radius and the diameter, because if you notice, I started at that center piece and I went to the outside. Well, that is the radius. So we know that that is 5 centimeters. And then from the center of the circle, the other direction, well, that's also the radius. That's also 5 centimeters. So we know that the diameter is 10 centimeters all the way across. So the diameter is equal to 2 times the radius. So if we know the radius is 5, well then 5 times 2, then we know the diameter is 10 centimeters. Okay, and you can use that relationship for no matter what the radius is, 2 times that is going to equal the diameter. So let's talk about the formulas. First, in these formulas, you are going to see this symbol pi. An easy way to write it is just simply a line with 2 parallel lines underneath it. Sometimes they're a little fancier than that with a little curve to them, but you'll see them written different ways. So pi is simply, it's a Greek letter that represents a math ratio. And remember, a ratio is a fraction. It's comparing two numbers. And it helps us find the circumference and the area. It's basically a ratio of the circle's circumference compared to its diameter. So pi equals, you guys probably know it's approximately 3.14, but the actual value of pi goes on and on and on forever. So if you go to your Desmos calculator, you will see a pi button, and if you click it, it gives you a certain, a little bit of the number, but this decimal actually goes on and on forever. It never ever ends. So it's an irrational number. So pi equals something similar to that. So the circumference, and again I'm going to change colors to show you on our picture up here, the circumference is all the way around a circle. So if we were to take a piece of string and lay it around this circle, and then pick up that piece of string and measure it, that is what circumference is. So circumference is basically the perimeter of a circle, so the distance around a circle. There's 2 formulas. So one of the formulas is 2 pi r, meaning 2 times pi times r. Or if you think about what is in this formula, the 2 times the r, if you just think about those, 2 times r, we talked about up above, well, that's the diameter. So we can also say that this formula could be pi times diameter. All right, now the area is a little different. Switch colors again. The area, and I'm going to go back to my circle up here, is going to be all of this space, all of that gray shaded region in here. That is what we call the circumference. So the area. The area is going to be the region or that space that is enclosed by the outside of the circle. So the region enclosed by a boundary. And the definition for area, it always stays the same with whatever shape you're working with. So the area of a rectangle, it's going to be all that space, that region that's inside the boundary of the rectangle. So the formula for this area, and we use a capital A for area, a capital C for circumference. So area is pi r squared. And r squared is different than up above. Our circumference was 2 times r. So that's totally different than r squared. And I'll show you why here in a couple examples. Okay? We're going to start with circumference. I'm going to do the 2 on the left side. So first we need to decide what are we given in this example. So we're given 4 centimeters. Is that the diameter or is that the radius? Well, it goes all the way across. So we know that this is what we call the diameter. So personally, what I would do is write down the 2 formulas, 2 times pi r or pi times diameter, and decide what are we given, which formula should we use. Since we are given the diameter in this scenario, well, I would use the formula that has diameter in it. It'll be less work in the end. So circumference, we're going to do pi times, I'm going to replace the variable d with 4 since that was what we were given in our circle. So pi times 4. Now, recently I've been seeing some questions that ask for the exact circumference or area, meaning exact with pi in our answer. So for pi, we can rearrange this order. For pi is actually what we call the exact answer. The second that we multiply by pi, well, then we are approximating, we are rounding the answer because pi is infinite. So we go to our calculator and we're going to put in 4 times. We want to use that pi button instead of 3.14. It's a more accurate answer. So 12.56. And then it doesn't tell us, but let's say we're going to round to the nearest tenth. So we're going to approximate it to about 12.6. Now, in this scenario, we were given centimeters, so make sure you label your answer in the end. So there's kind of 2 answers here. You always want to make sure and read the instructions to figure out which answer the question wants. Does it want an exact answer? Well, then that would be 4 pi, and it'd actually be centimeters. If it wants an approximate, it tells you to round. Well, then you would multiply, and you'd get 12.6 centimeters for the circumference. Both answers are the exact same. All right, I'm going to jump down to example 3. So again, figure out what are we given. I'm going to write down those 2 circumference formulas again. So 2 pi r or pi times diameter. And in this scenario, we're only given from the center to the outside. So up above there, that's what we call the radius. So this 9, the center to the outside, that's our radius. So we actually want to use the formula 2 pi r in this scenario. So we're going to keep the formula how it is, the 2, the pi, and then the r, the variable r, we're going to replace with 9. And what this means is everything is just multiplied together. If we want the exact answer, then we just multiply the 2 numbers, leave the pi in the answer. So 2 times 9 is 18. And then leave the pi there. So 18 pi, and this one's labeled meters. That is what we call our exact circumference. Okay? Then, last step, we can approximate it. So I'm going to go back to my calculator in Desmos. 18 times, again, use the pi button. And we get 56.54. And since there is a 4 next to that 10th spot, we're going to keep it where it's at. And I'm going to use this little approximate. So it's 56.5. And again, it is just a measurement. We're just measuring the outside of the circle, so we leave it as meters. And actually, I'm going to Again, box in both of these answers because they're the exact same. One is just the exact and one is the rounded circumference. So there's how we find circumference. Use those two formulas, figure out which one you want to use, and then you can just plug it into your calculator. Notice I am showing my work and what I'm plugging into the formula. At this point, I'd like you to try these two on the right side and see if you could get these correct. Then press play and see if you are on the right track. So all the way across, we know that the 23 is the diameter. So we have our two formulas. I want to figure out which one I want to use, 2 pi r or pi d. Since in this case we were given the diameter, we want to use pi times diameter. So the circumference is pi times 23. So the exact, and we often always see the number before the symbol, the letter, or the variable. So 23 pi, and oops, that was millimeters. That is our exact circumference. And then we can plug 23 times pi into our calculator to get 72.25. So if we're rounding the nearest tenth, that 5 next to the 2 tells us we need to round up to 72.3. So the circumference is approximately 72.3 meters. That's our rounded circumference. So there are our two answers. And last one with circumference, we have radius because it goes from the center to the outside. So the radius, ooh, that's a big radius, 58 centimeters. So our two circumference formulas, which one should we use? In this case, since we were given the radius, I would use the 2 pi r. So 2 times pi times the radius was 58. Then again, to get the exact, we just want to multiply the coefficients. So 2 times 58, we get 116 pi. And this one was centimeters. So that's our exact circumference. And then last step, we will round these. And at that point, you could actually plug all of this in at once. You can do 2 times pi times 58. And we get 364.4. And again, labeled with just centimeters. So there those are. Please fix those if you missed them, and you can see how you did on those two. So that is circumference. I'm going to pause there for now, and we'll do area then tomorrow.